All right, stats, how are we doing today? I've got for you the Chapter 10 quiz review. It is the review that says Intro to Probability quiz review, stat 1300, and it's got a lot of markings, different due dates in the past. But anyway, it is, and I've got it up on my Chromebook there. It's that. I sent you 2 different copies of it yesterday. Have this out, look at it, write these down. I have greatly abbreviated the questions because I don't have it printed out, and I have it right here. All right, so I'm gonna have to be out a little bit longer than I expected because I'm dumb in that regard and thought that the recovery would be easier. I've got a massive cast on right now that will have to be removed, cleaned up, looked at, hopefully made much smaller. Next Tuesday is my appointment. So I will be out at least through next Tuesday, but hopefully not much longer after that. I'm feeling very good. Thanks for asking. And should be really good to go in less than 2 weeks. So that is the goal, to see you in less than 2 weeks. All right, so number 1 says you have a spinner with 4 spaces labeled 1 through 4. All numbers are equally likely to be landed upon. You're going to spin the spinner twice and find the sum. Find the sum. So that's what x equals. Somewhere at the top right, x equals the sum. You have to define this. Now it says find the sample space for the 2 sums of the 2 spins. For the sum of the 2 spins. All right, so first off, I mean, you can only get sums of 2, 3, 4, 5, 6, and 7. So that is technically correct. But I'm going to want you to write it like this, especially when we're rolling dice here soon. In questions, not for actually betting. Okay, so don't add me on that one. In questions. So the whole sample space is this. So here's my first roll, here's my second roll, or here's my first roll, or here's my second roll. It doesn't matter. 1 and a 1 gives you 2, a 2 and a 1 gives you 3, a 3 and a 3 gives you 6, so forth. That's everything that can happen, and this is really important. Yes, this is true, but it's not going to help you out once we get through asking about probabilities. This is really useful. So write your sample space like that. So B says, again, pause this whenever you need to. B says, find the probability of getting a sum of 5 or more. You're going to explain your reasoning through the math. All right, so find the probability of getting a sum of 5 or more. There are 16 different sums. 4 by 4 gives you 16. So my denominator is 16. How many of these? I got 4 plus 3 plus 2 are 1. So x is a sum, and you got to write a probability statement. I want the probability that x is greater than or equal to 5. That's what 5 or more means. Of the 16 sums, 10 of them are 5 or more, which is 5 over 8, which is 0.625. A probability is a number between 0 and 1. All right, C says, find the probability of getting a sum that is less than 6. So the probability of getting a sum that is less than 6 means 6 ain't allowed, 7's not allowed, 8's not allowed. So it's really the probability of getting a sum of 5 or less. 5 or less. So there are 16 sums total, and 3 plus 2 plus 1, 6 of them are not allowed. I have 10 over 16 again. I have a probability of a sum of 6 or less, or less than 6. The sum is less than 6, or it's 5 or less. Those mean the same thing here because sums here are discrete, no decimals. Very countable. So my probability is, again, 0.625. Now, D is expected value. What is the expected sum one should expect? Now, we're going to do something a little bit different with expected value later on a GPA question, but in this example, like, what's the sum of all of my sums divided by how many there are? 16. So there's 1, 2, there are 2 3s, there are 3 4s, there are 4 5s, there are 3 6s, there are 2 7s, and there's 1 8. And there's 16 sums. So what do we got? We got 2 plus, we got 8, we got 20, we got 40, we got 38, we have 52, we have 6. Do we really? I think we have more than that. Am I messing up here? I'm not going to type this all in, so do check me. 2, we're at 8, we're at 20, we're at 40, We're at 58. We are at 72. We're at 80. So I messed up somewhere. I think it's 80 over 16. It's 5 exactly. The expected value is 5. Well, like 5's right in the middle. All right, so those two average to be 5. Those average to be 5. Those average to be 5, and 5's in the middle. Kind of makes sense. You would expect to get a 5. Okay? That is question 1. Then we go to question 2, and 2 is all about, can you play this game or not? So I'm going to read what 2 says. 2 says, there's a 30% chance of rain on Monday, 40% chance of rain on Tuesday, 25% chance of rain on Wednesday. If it rains at all, a high school baseball game will get canceled. What's the probability that you will get to play on exactly 2 of these 3 days? So probabilities all change here. Rain equals no game, and you play the game if there's no rain. So I want to know, what's the probability? Still write a probability statement. What's the probability that you play exactly 2 games? You don't have to write me an essay, but I do want a probability statement. So P for play, N for no play. So the probability you play exactly 2 games, the scenarios can happen like this. You can play, not play. You can play, not play, play. You can not play, play. All right. So in this first scenario, when you play the first 2 games, you don't play the last. Again, if there's a 30% chance it rains, there's a 70% chance you play. 40% chance it rains, 60% chance you play, 25% chance it rains, 25% chance you don't play. Again, you got to write it out. This is what you want to happen. That's point 105. Then if you play, don't play, play. Again, 30% chance it rains, 70% chance you play. If you're not going to play, that's a 40% chance, so 0.4. And if you're going to play on that final day, 25% chance it rains, 0.75 is the probability that it doesn't rain and you get to play. You don't play, you play. All right, if you don't play the first day, that's because it rains. That's a 30% chance. That's what it is in decimal. Then you play the next 2 days, so it doesn't rain. 40% chance it rains, 60% chance it doesn't. 25% chance it rains, 75% chance it doesn't. Add up the probabilities. That's the probability that you play exactly 2 of the 3 days. B, what's the probability you get to play all of the 3 days? Probability play all 3, probability of 3 straight playing. So it's the complement of the probability that it's going to rain. 0.7 times 0.6 times 0.75. Instead of raining, it doesn't rain. So almost a third chance you get to play all 3 games. What's the probability that you get to play no games? That means it literally rains every single day. 0.3 times 0.4 times 0.25. All right, Grandma's in town. What's the probability that she gets to see you play at least 1 game? All right, so probability at least 1 game. You just want to do 1 minus the probability that you play no games, which is 1 minus that, which you found in part C. 97% chance you play at least 1 game. And then what's the probability that you play at least 2 games? Well, we already have this. From part A, that's the probability you play 2. And from part B, that's the probability you play 3. Probability you play at least 2 games is probability you play 2 games plus probability you play 3 games. So that is at 0.765. That's a good question, folks. That's a good one. So when we get into probability, the incredible easiness of chapter 1 might change a little bit. So really take your time and focus. We are in that part of the class now. All right. You are an 85% free throw shooter, and you're going to shoot 2 free throws. Yogi, you've been warned. All right, Yogi's with us here right below. Yogi, poor dog, was locked up yesterday while making videos, so I felt a little bad. I'm giving him a chance. You were good, Yogi, in the calculus video. Let's continue that. So what's the probability that you're going to make exactly 2 of the shots? You're going to make both of them in part 3A. X is a made free throw. The probability stays consistent the entire time, so in our probability statement, we will use X. What's the probability that X is exactly 2? That's 0.85 squared, rounded to 2 decimals. You guys can do that for me. I can also do it here. My calculator will turn on. 7, 2, 3. What's the probability you make 1? Here's what happens. You make it, miss it. Or you miss it, make it. That's the same probability twice. 0.85 times 0.15 if you wanted to. It depends on how you round. I mean, you get this, and you're literally just going to double it. So you can do just times 2 in your calculator. It's exactly 255. Now, if you round this up to 128, you can get 256. So you can be off by 1,000th. That's fine. Okay. And what's the probability that x greater than or equal to 1? You can either add part A and B together, or you can do 1 minus the probability x is 0, which means you miss them both. Yeah, you can't really see that. If I do 1 minus, so that would be 1 minus 023, if I rounded it, which should be, 77. If you don't round, then it rounds up to 978 if you don't round. If you do it the way I do, it's 977. Again, with rounding, you can be off by 1,000. That's no big deal. Number 4, you're 76% free throw shooter, and you're going to attempt 3 free throws. Whoa. X is a made free throw. Probability of X is 0.76. Up top, I forgot to mention, probability of X is 0.85. What's probability you make all 3? Make. That is 0.76 to the 3rd power. That is 0.439. Can show all this work. What's the probability that you make 2 or more? Well, it's what we got for making 3, and then we got to figure out what's the probability that you make exactly 2. Here are all the scenarios of making 2, exactly 2. Make it, miss. Make it, miss it, make. Miss it, make it, make it. Now again, I would be sharp here. I would just type in what's going to happen. You're multiplying 0.76 by itself twice. Then you're multiplying it by 0.24. That is happening 3 different times. 2 7/6s and 1 2 4. So find out what that is. All right, and then just multiply it by 3. Now, depending on rounding, if you said, all right, all of these are 139, if you round that up, and then I can get your emails while I'm making these videos, notifications, and that was a funny one. All right, so 417, just like I made the video yesterday, 2 or 3 of you submitted your homework, so solid job. So if I round one of these to 139 and multiply it by 3, I get 417. That's fine. Now, if I take the 0.76 times 0.76 times 0.24, you guys are, one class is really on the emailing me. Fantastic. And I multiply it by 3, that would round up to 416. So that's probably the exact one, 416. Again, it's just off by 1,000. That's no big deal. It's going to add to 856. All right. Then what's the probability that you make at least one of them? It's 1 minus probability you miss all 3. That's the probability you miss all 3. So it's going to be 1 minus, what's the probability you miss all 3? 0.24 to the 3rd. 014. So that should be 986. Almost a 99% chance you make one of the 3. All right. That is the answer for number 4. Then we go to number 5. And 5 gives you the grade distribution of a Calculus 2. Yogi, we're going to be nice and calm. Using the standard of 4, 3, 2, 1 is 0 scale, find the overall Calc 2 GPA. That's like the expected value here. All right, so you get 4 points for an A, 3 for a B, 2 for a C, 1 for a D, and no points for an F. So I take the value of X and I multiply it by the probability of X. The value of X times the probability of X plus the value of X, 3 points for a B, times the probability they got that, plus the value of a C, which is 2, times the probability they got that, plus the value of a D, 1, times the probability they got that, and plus the value of an F times the probability that they got that. And then I add them all up. So I'm going to do a little math by hand here. I got 4, 4 plus 7, 8 plus 6, 8 plus 1, 1. I should probably have a 0 there. All right, that's 122,190. I think it is exactly the C average. All right. Value of x. 0, 1, 2, 3, 4. This is the non-word. You had this in your notes yesterday. This is the non-word errors. So x is the number of non-word errors. They told you that. So is x discrete or continuous? It's discrete because the errors, which is x, they're countable. They're countable. They literally go from 0 to 250. All right. You guys are emailing machines right now. It's between 0 and 250. You can't make 251 errors. So it's countable. There's no decimals. It's discrete. So anything I just say, write that down. The number of errors are countable. No decimals. It's definitely discrete. At least one at least one non-word error. Write it. At least one. So that the event is x is greater than or equal to 1. So I want to know what's the probability that x is greater than or equal to 1. That means 1 minus the probability of no errors, which is this. This is one you're going to see again. Obviously, it's not a quiz review. And this question has kind of tripped up some students. Okay, so we got to start thinking and just being real careful. So describe this in words. So just listen. I'm going to say it slowly. This means 2 or fewer non-word errors. 2 or fewer non-word errors. And then what is its probability? All right, it's probability that x is less than or equal to 2. It's probability of no errors, 1 error, and 2 errors, which, if I can do that mental math, is 0.63. What is the probability that x is less than 2? That means you get 1 or fewer. That's another way to write it, 1 or fewer. It's probability of no errors. It's probability of 1 error. Just don't count 0.22. That's 0.41. All right. I believe we have 2 more. Number 7. All right, this is a good one. This is where do you reside and how old are you? So 23. So getting out, out of college, you might be 22, you might be 23. You're probably definitely out of college unless maybe you did an extra year. All right, so Yogi, that was my pen. Calm down. So we got 23, 24, 25, 26. Those are the different ages. And do you live with your parents? Are you in an apartment or do you own your home? Now that means like you have your own home. You don't own it, right? I think I own my own home, but I owe the mortgage company $160,000. So that's what they mean. It's not totally paid for. You're just in a home, not an apartment. There's a big deal. Difference, you're paying a mortgage, not rent. All right, let's talk. What's the probability that the person is 25 who owns their own home? So you're looking in a single cell here. They are 25 and they own their own home. So you would write that. You're going to make a probability statement. Probability 25 with own home. You don't need to write me an essay. Probability 25 with own home. And that is exactly that one, 0.10. What's the probability that they're 26? Probability of a 26-year-old. Probability they're 26 is you add up this column, 03, 05, 12. That's 0.20. It's probability that they live with their parents. Probability lives with parents. All right. 17, 09, 05, 03. That row. And I'm just going to do some mental math. That's 23 and 24. And this is 25 and 26. And that's a third of them. What's the probability that they don't own their own home? Probability, no own home. That's really terrible English. Show that to Mrs. Lamore or Mr. Crest, please. You... All right. Some of you should be watching videos instead of sending me emails. Though, your goodness. Your humor making me laugh. Okay, thank you. That's one of the best medicines, right? Probability that the person doesn't own their own home. Did we find the probability that they own their own home? No, we didn't. So, what is the probability that they own their own home? I am going to add this row up. That is 12, 22, 34. Oh, I think my doctor just called. So we're going to finish this up. 0.66. All right, what's the probability a person chosen is over the age of 24? That means they're 25 or 26. Probability that they're 25 or they're 26. So probability that they're 25, I'm going to add this column, and that is 0.24. And then probability that they're 26, I'm going to add that column, and that is 0.20, and that is 0.44. All right, probability the person chosen is 26 or they live in an apartment or both. Now, we got to be careful here because I'm going to overcount. That's the probability that they're 26, and this is the probability that they are in their own apartments. But if you follow the overlap, you'll be counting 05 twice. You're going to be doing overcounting. So there's one of two ways you can do this. You can find the probability. So probability that they're 26 union... We'll talk about union later, that they also have an apartment. So anytime you do a union one, we're going to talk about this in Chapter 12, you can find the probability that they're 26, which is 0.20, and you can add that to the probability that they live in an apartment, which is got to be 3.2. But you've overcounted the 05. You counted it twice. So 5.2 minus 05 is 4.7. And if you add individually all the numbers... add up these, 2.0, and then add up these. Don't count that again. You'll get 0.47 again. All right. So I'm going to try to finish this up because I do believe my doctor's office just called. So, this one says Mr. Yak. Obviously, Mr. Yak does not have any races upcoming in the next month. So we're just going to call this person the hero in the story. He has 3 upcoming races. They have a 75% chance of winning the first race, 30% chance of winning the second race, and a 35% chance that they win the third race. All right, we got to finish this. What's the probability that they win all 3? Probability win all 3. That means you win the first race, you win the second race, and you win the third race. And you're going to help me out with that. Round to 3 decimals. What's probability you win at least 1? Probability win at least 1 is 1 minus the probability that you win 0. And the probability that you win 0 is, well, I lose the first race, I lose the second race, and I lose the third race. 1 minus that. So actually, we need to find the probability that they win all 3. It is 0.24 is your first answer. The probability of losing all 3, that means winning is 0. Syntax error. Okay, 0.55 times 0.7 times 0.65. Probability of not winning any is 0.250, so that's probably they win at least 1. All right, so probability of winning at least 2. We know the probability of winning all 4. That's 0.4. So first off, we need the probability of winning 2. And here are the 3 different scenarios. I could win the first one, win the second one, and not win the third one. You could win the first one, not win the second one, and you could win the third one. And you could not win the first one, and then you could win the second one, and then you could win the third one. Now, I do need to find all of these because they're all different. All right. So 0.45 times 0.30 times 0.65. That's going to round to 0.88. Then I have 0.545 times 0.7 times 0.35. That is 110. Then I have 0.45 times 0.30 times 0.35. That is 0.58. That is the probability of winning exactly 2. So 0.88 plus 110, 0.110 plus 0.58. Probability of winning at least 2 is 256. What's the probability of winning? The probability of winning 2 is 0.256. So the probability of winning at least 2, probability wins at least 2 is going to be probability of winning exactly 2 plus probability of winning 3, which is just under 30%. What's the expected value for the number of races hero wins? All right, so first off, probability that I win is 0, though 0 times anything, it's 0, is that I don't have the probability of exactly 1. I have at least 1. I do know the probability of winning exactly 2, and I do know the probability of winning exactly 3. So I need to know the probability of winning 1. So the probability, now x, we're just going to call x a winning race here. You can put probability winning at least winning 1 race exactly. Here's what could happen. I could win, not win, not win. All right. Then I could not win, win, not win. And then I could not win, not win, and win. And we're going to find those probabilities. We're going to add them all up. 0.45 times 0.7 times 0.65. That is 205. That is 55 times 0.3 times 0.65. That is 107. It's 55 times 0.7 times 0.35. That is 135. Add them up. 205, 107, 135. Probability of winning exactly 1 race is 0.447. Okay, so why is that important? 0.447. The expected value, call x winning a race. The expected value of x is, all right, the value of winning 0 races, times its probability, plus winning 1 race times its probability, plus winning 2 races times its probability. It's x times the probability of x, the sum of that. Winning 3 races times its probability. So 447 plus 521 plus 126, right? And then you just find that. All right, this is a pretty long video. Tomorrow I'm going to give you some homework help, and then on Monday you're going to start something new. And I'll try to email you that beforehand if I can. Tomorrow we're going to start something new. All right, this is Yak Math Videos signing out.